Okay, let's do this Trig Sub Worksheet. We'll start with this one. So I'm going to make a triangle, a right triangle, and it's 25 minus x squared, so the 25, the square root of that goes on the hypotenuse, and then the square root of the x squared can either go on either side here. I'm going to put it here. So the Pythagorean theorem says a squared plus b squared equals c squared, so c squared minus a squared will equal, and square root of it, it's b squared, so it's going to be this side would be the square root of 25 minus x squared. Now writing that out, I have x squared plus, I'll just call this b squared equals 5 squared. And so if I solve for b, I subtract the x squared, and then I take the square root to get rid of the square, and I get 25 minus x squared for this side. So that's why I put this on the hypotenuse and this on one of the legs, and the other leg will be the square root of 25 minus x squared. Then in Trig Sub, the way I teach it, I say, come up with a simple expression for x. Well, x using trig. Now, if I use this and this, I'd have tangent, but that's not the simple. The simple would be x over hypotenuse, opposite over hypotenuse, if this is the angle, and I like to put it there. Opposite over hypotenuse is the sine of the angle, so it'd be x over 5, but then I like to multiply both sides by 5. So I get 5 sine theta is what x is. So that's figuring out what x is, then figure out what dx is. So I take the derivative of there, and I get dx equals, and the derivative of 5 sine theta is 5 cosine theta d theta. And then we have this square root thing, and I want an expression for it, the simplest I can do. And I just call this the mess, the hard part of this integral. And so if I could do this to that, or I can do this to that. This is simpler with a 5 than it is with an x. So I'm going to go the square root of 25 minus x squared over 5. That's adjacent over hypotenuse, adjacent to the angle, hypotenuse. So adjacent to hypotenuse is the cosine. But I'm going to multiply both sides by 5 to get rid of this 5 down here. So I have this mess is 5 cosine theta, dx is 5 cosine theta d theta, and x is 5 sine theta. So now I can do my replacements. 1 will stay 1. X squared becomes 5 sine theta quantity squared, so that's 25 sine squared theta. And then I have this also down there, which is 5 cosine theta times, and then I have dx, which is over 1, so this can go in the numerator, so I have 5 cosine theta d theta. Now I'm going to do some trig simplification. The 5 and the cosine theta cancel, and I have 1 over 25 that I can pull out because it's a constant times things, and so I'd have 1 over sine squared which is messy, but sine squared, 1 over sine, the reciprocal of sine, 1 over sine, the reciprocal sine, is cosecant. And since it's sine squared, this would be cosecant squared theta d theta. And cosecant squared's antiderivative. So what do we take the derivative of to get cosecant squared? We take the derivative of cotangent. We get negative cosecant squared. So this would be negative cotangent. So we get 1/25 negative cotangent theta plus c. But I made up the theta, so I need to go back to x. So cotangent is not tangent, opposite over adjacent, but adjacent over opposite. So this is negative 1 over 25 adjacent square root of 25 minus x squared over opposite plus c. Now, this one you might be able to do with substitution or some other method, but that's the end result that you should get. Now, this one, if I'm doing trig sub, the mess is this. So I'd make my triangle again, but this time I'd put the x on the hypotenuse and 2, the square root of x squared, x on the hypotenuse, and this on one of the legs, because the legs are always subtracted from the hypotenuse. So I can put 2 there or there. I think I'll put it there. When we're doing it, it'll look different, but when we're done, it'll look the same. If you do, you just keep going consistently. So this becomes hypotenuse squared minus a leg squared is the other leg squared. Hypotenuse squared minus a leg squared is the other leg. Then I have my list of things to do. Find x. Simplest one, well, that would be hypotenuse to the 2. So x over 2. See, 2 over x, adjacent over hypotenuse is cosine. So x over 2 is the reciprocal of cosine, which is secant. And if I multiply both sides by 2, then I have x is 2 secant theta. And then if I take the derivative, I get dx. That's the second thing I want to find. And so the derivative of 2 secant theta is 2 secant theta tangent theta d theta, and then the mess. I can go this to x, but simpler would be this to that. So that's opposite over adjacent. That's the tangent. And I can multiply both sides by 2. So the mess is 2 tangent theta. So this problem becomes x to the third. So that's 2 to the third secant of theta to the third. So that's 8 secant to the third theta. The mess is 2 tangent theta the dx is 2 secant theta tangent theta d theta. So this goes to this. The 2 cancels the 2. Tangent theta cancels the tangent theta. The 8 comes out. Secant to the third times secant is secant to the fourth theta d theta. It's tempting to try to call this secant squared theta times secant squared theta, which it is, and then try to integrate individual pieces. Now, if it was secant squared theta plus secant squared theta, that would work. But since they're times, you can't do that. So we go to our formula page. Let's see if I got it here. And here's secant to some power of x simplifies. So I'm going to use that. See if I can get it all on the screen. I think we got it there. So in this formula, m is 4. So I have 8. Actually, I'm going to have a couple things here, so I'm going to put a bracket because we're going to have 2 things. Tangent of x, but x is theta, and secant to 2 less than m was 4, so 2 less than 4 is 2, so that'd be secant squared theta over 4 minus 1, 3, that's this, plus 4 minus 2, 2, over 4 minus 1, 3, antiderivative of secant to 2 less than the power it was. So it goes from 4 to 2. Well, that did do what we were kind of hoping, get a secant squared. No integral on this, so this is done. So we have 8 times both of these, tangent theta secant squared theta over 3 plus 2 thirds. The antiderivative of secant squared is tangent theta plus c. And so we get 8. Now we got to go back to x's, so I got to look at the theta and figure out what the tangent is. Well, that's that over that, so that's square root of x squared minus 4 over 2, there's the tangent, times the secant. Well, the secant was x over 2, and both of those are divided by 3, which is the same as times 1/3. So I get a denominator of 12. I get this x times this over 12. I'll rewrite that in a sec here. And we get 2/3. Tangent, again, was this, opposite over adjacent. So it's square root of x squared minus 4 over 2. plus c. So writing this more simply, 8 times, it would be 8 over 12, but 4 goes in 12 and 4 goes in 8, so it'd be 2/3 square root of x squared minus 4 times x plus, these twos cancel, so it'd be 8/3 square root of x squared minus 4. Okay, next one. So now we have both of them added. How do I make that on a triangle? Well, if I put x on one side, one leg, and 4 on the other, then a squared plus b squared, they would add and then take the square root. So I'll put the x there and the 2 there, the square root of x squared, and the square root of 4. And so the hypotenuse would be a squared plus b squared, square root would be c squared, and then we have to take the square root. So this would be the square root of x squared plus 4. And that's theta. So the first thing is the simplest for x. Well, x over 2 is opposite over adjacent, or tangent of theta. Multiply both sides by 2. So 2 tangent theta is x. Take the derivative, so we get dx is 2. Derivative of tangent theta is secant squared theta d theta. So we got x, dx, and mess. That's this thing. Well, we can take this to that, would be messier than this to this, so I'm going to use that. So the square root of x squared plus 4 over 2. See, 2 over that's adjacent over hypotenuse is cosine, so this over that is the reciprocal of cosine, which is secant. And I multiply both sides by 2 again. And this is what the mess is. So this problem becomes x to the third. Well, that would be 2 to the third tangent to the third. So that's 8 tangent to the third theta over the mess, which is 2 secant theta, and the dx is 2 secant squared theta d theta. Now we've got to simplify. One of the secants will change this to 1. This 2 will cancel that 2. And so I'm going to have 8 that pulls out because it's times everything. And tangent and secant, tangent to the third and secant. So I'm going to switch to sines and cosines. Tangent is sine of theta over cosine theta. And since it's to the third, I'm going to have 3 of these multiplied and 3 of those multiplied. And secant is 1 over cosine d theta, which is looking pretty ugly. However, it's the sine to the third theta over cosine to the fourth theta, because we got 1 cosine times 3 of them there. So if I let u be my denominator, doing a u sub, just the cosine, du would be negative sine theta d theta, and this would become 8 antiderivative. I let u be cosine, so I don't have anything for the sine. Cosine is u, so this is u to the 4th, and d theta is du over negative sine theta. So the negative comes out, and it comes out in the denominator, but it doesn't matter, it can go in the numerator. And I have one of the signs cancel, so I'm going to have sine squared theta over u to the 4th du. But sine squared is 1 minus cosine squared, if you remember the Pythagorean theorem in the trig. So this, if this is 1 minus cosine squared, it's 1 minus u squared. So this becomes negative 8 antiderivative of 1 over u to the 4th du minus the antiderivative of cosine squared. So 1 minus cosine squared, which is u squared, over u to the 4th. And since this is just u to the negative 4, and I integrate it, I'll add 1 to this, so it becomes u to the minus 3 over 3, minus 3. That's the antiderivative of this, minus the antiderivative of this. Well, this is u squared over u to the 4th. That's really just, these will cancel 2 of them, and I have u squared in the denominator, or u to the minus 2. So I add 1, and I get u to the minus 1 over minus 1 plus c. Now we have to go back. So negative 8 times this over negative 3 is positive 8 thirds, and u to the negative 3 is over u to the 3rd. And minus 8, these minuses cancel, so it's just going to be minus 8, and u to the negative 1 is 1 over u. So u was cosine theta from up here. So this is 8 thirds, 8 over 3 cosine cubed theta minus 8 over cosine theta plus c. Now I got back from u back to theta, and now I got to go back to x's, and the cosine would be 2 over that square root adjacent over hypotenuse. So this would be 8 over 3, and this is in the denominator, so this is 1 over cosine, which is the reciprocal, so it's going to be this over 2 if I move this to the numerator. Call it secant cubed theta by taking it out of the denominator, and the secant would be this over that over that. So this is going to be square root of x squared plus 4 over 2 to the 3rd minus 8 This comes up as secant, and secant's, again, the square root of x squared plus 4 over 2, and this is just to the first, plus c. Now, this 2 would go in the 8, this 8, 2 cubed is 8, would cancel the 8. So if I took it one step further, and 2 into 8 is 4. Okay. Now this one. So the x is being subtracted from the 1, so I got to put 1 here. The square root of 1 is 1. And x on one of these legs, I'll put it here. So then this side would be the square root of the hypotenuse minus the leg squared. Hypotenuse squared is 1 minus x squared. If that's my theta, then x over 1 is the sine of theta. So taking the derivative, I get dx is cosine theta d theta. And then solving for the mess, I guess I'll put this over that, which is cosine theta. Square root of 1 minus x squared over 1 is cosine theta. So this becomes the mess, just cosine theta, x to the 4th, and dx is cosine theta d theta. So we have cosine squared but cosine squared is one minus sine squared, and we can put that sine to the 4th under both of those. And sine to the 4th, sine 1 over sine is cosecant. So I have the integral of cosecant fourth d theta minus the integral of 2 of these, cancel 2 of those, so I get 1 over sine squared. 1 over sine squared is cosecant squared theta. The antiderivative of this is negative cotangent theta. So we got minus and minus, so that's plus. And then this, I'm going to resort to my handy dandy formula page, and here's cosecant to a higher power, and this will reduce it by 2. So this will become the integral of, not the integral of, cosecant to the 4th, m will be 4, so I get cotangent x cosecant of 4 minus 2, 2x. Oh, but that's theta, so I better put thetas. Over m minus 1. M is 4, so this would be over 3 with a minus in front. Plus 4 minus 2 is 2 over 4 minus 1 is 3. Antiderivative of cosecant to 4 minus 2, which is 2, theta d theta. That's this part. And then we have minus minus plus cotangent. So we got to find the integral of this, but that is cotangent, negative cotangent. So we got negative cotangent theta cosecant squared theta over 3 plus, actually, minus, because this is going to be negative cotangent, minus 2/3 cotangent theta minus a plus, minus minus plus a cotangent theta plus c. So minus 2/3 cotangent plus a whole one. This would be just minus 1/3 cotangent theta. These two together. So now we're in cotangents and we're back into thetas. So we got to get back to x's. So I need to use the triangle. See if I can get this where you can see it. So I need minus cotangent. So tangent's opposite over adjacent, so I got to do adjacent over opposite. Square root of 1 minus x squared over x. That's this. This is all times 1/3 because of that 3. And then cosecant is the reciprocal of sine. Sine is x over 1, so it's 1 over x. 1 over x, but it's cosecant squared, so 1 squared is 1 and x squared. And then we got minus 1/3 cotangent, which we decided was adjacent over opposite. Square root of 1 minus x squared over x. Okay. That's the Trig Sub Worksheet.